Okay, so we have the presentation fresh off the build process. Let's see if we can get started from the top and kick this off. My name is Mihai. I'm the CTO for Cloud Native and Red Hat Solutions at IBM. I'm also an RHCE, and I'm going to introduce a number of tools that can help improve your container build and management process, but also give you hands-on getting started with OpenShift and Kubernetes over the next couple of sessions. Over the next 3 sessions, we're going to cover, just to give you an overview on day 1, that's today, how to work with Podman, Buildah, and Skopeo, and the Red Hat Universal Base Image to build and manage containers. On day 2, that's going to be next Friday, we're going to go through the process of publishing images to an external registry, working with Quay and Claire, scanning your images for security vulnerabilities and other image build best practices, as well as how you can use your external container registry to perform the actual build. On day 3, that's going to be in 2 weeks, again on Friday, we're going to set up and install code-ready containers or OKD, create a project, let's call it WordPress or MySQL as an application, and set up users, groups, HD password authentication, deploy a database, deploy a container, create the route, and scale out the application. We're also going to take a look at something called the operator hub and see how operators can help manage applications automatically in a Kubernetes platform. And we'll see if we're going to do any more sessions to continue the story, maybe set up a couple of monitoring systems or take a look at some of the performance monitoring in Kubernetes. You can join these sessions at any time. So if you miss, for example, day 2, don't worry. You'll have images there that you can take a look at. You can just get started on day 3. The goal is to have self-contained 1 hour, getting started with the technology kind of sessions. And we're going to kick it off today with Podman, Skopeo, and Buildah. So first of all, let me give an introduction to Podman. What is Podman? Well, just like the name implies, Podman manages pods, containers, and container images. And it can also create and run container images that adhere to the OCI standard. It's compatible with Docker, compatible with Docker Hub, and can be used to build and run images for Kubernetes or OpenShift or any other platforms that use the same OCI standard for the images. Now, you're probably used to using other container build tools or ecosystems, and the question is going to be, how is Podman different? Well, it's different in 2 key ways. One, you can run it as a regular user without requiring root access, so you can build and manage and run container images using a fork exec model instead of a client-server model. So containers are a child process of Podman. So you don't need to have like a Docker daemon, for example, to run your containers. You can run them as root. Although that does come with a couple of implications. For example, privileged ports cannot be bound to anything below port 1024, 1023 cannot be bound as a regular user. So you're going to need to build your containers to use a non-privileged port, as an example. It can also manage pods, so groups of 1 or more containers that operate together. Think of this as Kubernetes light, really light. So just like in Kubernetes, you can manage groups of containers that operate together in the form of a pod. The same way, you can manage pods with Podman. The second tool I want to show here is Buildah. Buildah is a tool that can be used to build container images from the command line or using a Docker file, and images can be pushed to any container registry, including Quay.io or Docker Hub or the OpenShift container registry or anything that you'd like to use, private or public. It's often used to build secure container images that run inside the lockdown container by a tool like Podman or OpenShift or Kubernetes or Docker. One of the advantages of Buildah is that it also simplifies the container build process. You don't always have to use a Docker file, so you can also build your containers using a simple shell script, and it will figure it out for you. So I'm going to show you a bit on how Buildah can be used. I'm also going to talk about the universal base image, or UBI, which is a secure and maintained universal base image from Red Hat, where you have access to an operating system along with patches, along with a health status. So think a bit like a rel type image, right? Where you have the support, you can understand that the image has been secured, you know the health of the image, and it's maintained by a vendor. This tends to be a response to some of the issues that we typically see with container images on public registries, which often may not have a maintainer, or you don't know if the image itself is in good shape, what's the security index. So to give you an example of that, here we have the Red Hat ecosystem catalog, where you have container images. So think of it like a container registry. But in addition to what you typically find in a container registry, what you'll find here is a health index of the image. So if I go to the security section, you'll see this image does not have any critical or important security updates that haven't been applied. And the health index actually decreases if the image hasn't been maintained in a while as well. It will also tell you if the image can run in privileged or unprivileged mode. So, for example, this image does not require elevated capabilities, which is quite important. I typically find that 90%, more than 90% of all container images built out there require root, right? They don't use a regular user. They bind to a privileged port, and really haven't been built with security in mind. They've been built with ease of access in mind, right? Everything runs as root. Even if it's inside a container, that remains a very bad security practice. So the images that are built on this ecosystem catalog can also be pulled down and used like regular images, but you have a lot more information about the security of the image, how the image itself is built. So you can find the Docker file here as well. And here's more information about the image. You can pull it from the container registry. Okay, the last tool I want to highlight here is Skopeo. So Skopeo is a tool to inspect and copy container images between different container registries, and you can also copy images from a host as well from a container environment. You can inspect images, and you can also use signatures to create and verify images. So Skopeo, think of it as your friend when it comes to moving images around, ensuring that you have the right image, that you're able to verify the signature of an image and so on. Now, this is going to be a bit of a hands-on session, so I'm going to show you some of these things in a environment. If you want to get started yourself, you're going to need a Linux system. I recommend Fedora 32, Ubuntu, and Debian are also a possibility as well. And if you're running something like Linux as your host, you can use boxes, which is similar to VirtualBox or VMware, to install various operating systems. So here you can say, I want to create a virtual machine, and you select Fedora, you click it, and it will magically install it for you and make it available, and you can perform all of your testing inside. If you're running on a Mac, try VirtualBox, try a Linux image as your host. Now, to get started, you're going to go to podman.io. All these instructions and presentations will be shared by Monday, so you'll have them available on the Meetup page, along with some instructions for how to get started with some of the next steps, like OKD or OpenShift or Kubernetes. So first, let's start by installing Fedora, installing Podman on a Fedora system. So as you can see here, the instructions are fairly straightforward. You install Podman, Buildah, and Skopeo. Those are the tools that you're going to use to build containers, and we're going to take a look at some of the things here. So let's do it on a Fedora system. I'm now running on a Fedora 32, 64 bit. We're going to install Skopeo Buildah and Podman, you'll see that they're already installed on the system. Nothing to do, and we're going to get started. So first thing first, let me make this a bit bigger so you can see. We're going to take a look at the version of Podman that we're using. We're using version 2, and take a look at our system and how it's configured. And this is actually very good information. So Podman info is the first thing you want to check out, because it will tell you a few interesting details on how Podman is set up. So here I have Podman actually set up to run as a regular user. As you can see, I have here rootless equals true. So I don't need to do something like sudo Podman. You also see an interesting thing here, which is the registries, which I have set up. So by default, if you're using Podman, you'll see that it searches a number of container registries in order. So first it's going to go to Fedora projects, then it's going to go to redhat.com, then it's going to go to CentOS, then it's going to go to Docker Hub to search for any images that that you give it. Now, that being said, let's take a look how we can change the order and change the registries that are configured. So the configuration file is in etc containers registries.conf. We're going to edit this file, and you'll see here search registries is defined in this list, and the order is also specified here. So if I do a Docker search or Docker pull HTTPD, it will first go here, then here, then here, then lastly there. So now that you know how to configure your Podman, we're going to take a look at some basic capabilities. So first thing first, let's search for an image. Let's search for something called HTTPD. And remember what I told you about the search order. Now, that's a lot more information than I expected. Docker search HTTPD returns a lot of stuff, right? So what I'm going to do here is I'm going to apply a filter. I'm going to filter for the official column. So you'll see that images have a number of stars, and they also have a flag called is official. If an image is official, you can at least not necessarily guarantee, but think, hey, this is an image that comes from the HTTP project, it's been verified. You can also see has a high number of stars. It's usually not a good idea to grab a random image off Docker Hub that isn't official, that doesn't have any stars, that nobody is using. You'll find sometimes maybe they have a Bitcoin miner inside, sometimes it hasn't been updated in 2 years, sometimes it's a poorly built image, sometimes it runs everything as root. So that's not always a good practice. So let's take a look at what's inside this image. We're going to use Skopeo, and we're going to use the inspect option. We're going to take a look at Docker IO, library HTTPD, and that will tell us a bit more about this image. So let's scroll back up, and we can see we have a digest and we have a number of tags. So I can pull this image, I can pull the latest, I can pull the Alpine version, which is going to be a lighter weight, but based on an operating system which isn't necessarily as secure as we wanted, or isn't necessarily coming with the right nulibc or options to have a supported product, but it's fast and small. So there's your trade-off, right? And you can see I'm going to choose maybe this tag or this tag to pull an image and take a look at it. So let's pull an image. Now I'm going to pull the Alpine version, which is going to be very small and lightweight, but it's also likely to be insecure or not work properly in a lot of situations. As you can see, this is a tiny image, and I'm going to check Podman images to see that I've pulled the image, and you can see HTTPD Alpine, and I have the image here as well. Let's pull another image called latest. And as you can see, if I do a Podman images, you'll see that HTTPD Alpine is here, is the same tag as this one. And if I take a look at this other one, which is HTTPD latest without the Alpine tag, you'll see it's a slightly bigger image as well. Okay, so now that we have a couple of images, let's take a look at the next step, which is how do we run an interactive session on a container? So we'd like to run perhaps a different operating system. As you remember, I'm running Fedora. I'm now going to do Podman run. I'm going to name it Ubuntu. I'm going to give it a host name as well. Let's call the host name Ubuntu. I'm going to use the -IT flag, so minus interactive and TTY. I'm going to run the Ubuntu image, so this will pull Ubuntu latest, and I'm going to run bin bash inside that image. And as you can see instantly, since I already had the image pulled, I'm now running inside Ubuntu. I can do Ubuntu things. All right. Now, we don't really want to run most of our images interactively, right? We want to run things in a predictable manner. We want to do different things with it. But first, let's take a look at how what happens once I exit my image. So if I do a Podman PS, you'll see that I'm not actually running Ubuntu. I've exited it. So if I do a PS -all, you'll see that Ubuntu here has just exited 16 seconds ago. So this is stopped. I can restart. I can do another interactive session and I'm back. If I open up another terminal window here, I can do Podman PS and you can see that this is actually started. If I go back to my previous terminal and I exit and I do a Podman PS again, the image is not started. So I can see it here, it has exited. Now, I'm going to remove this one and I can also do a Podman run and I'm going to add a --rm flag here. This is a quick test, right? So I'm doing something quick. I'm exiting. And as you can see, if I do a Podman PS -a, what you'll see here is that the image was automatically deleted after creation. Cool. So we know how to run containers in an interactive fashion, but that's not very helpful for most use cases, right? We want to run them in the background. So let's take a look at a container for HTTPD. So I'm going to retrieve a container and run it in the background and also bind it to port 8080. So let's take a sample container which runs HTTPD. So I'm going to use a detach flag here. I'm going to use publish. So I can publish this port on my machine to 8080 on or inside the container. Now, oops, which I already have running, so I'm going to stop. That's why you sometimes want to run things with -rm. Let's try it once more. Remember what I told you, that here I'm binding port 8080 on my host to 8080 inside the container. My container is running as an unprivileged container, right? It's running as a regular user. In fact, if I take a look at my PS, you see that my containers are running as my username as a regular user process, and it's forking off this container image. So since I'm running as a regular user, I can't bind to a privileged port. So this container image specifically was built to bind to port 8080. What do you think would happen if I had a container like the regular, Apache image binding on port 80? Well, it wouldn't work, right? That requires a privileged port that runs as root. You don't want to do that. Now, let's take a look. Does this work? I'm curling my web page. And yes, this is a test page. Excellent. Okay, so let's take a look at Podman PS. And let's stop these containers. Stop this one as well. All my containers are stopped. Let's do another run of HTTPD pod and start HTTPD because it was stopped. And let's do a podman inspect HTTPD. So the inspect command gives you a lot more information about the arguments that are started with your container, the image name, information on your network and configuration, the IP of your container, network mount points. So here you can see the ports that I'm mounting, for example, 8080 to 8080 inside using host IP and other information on the container. There's also a very cool flag if you don't want to remember the name of your container, -L. It will always look at the last started container. So you can inspect the last started container. With the same idea in mind, I can use Podman logs, HTTPD, and here we go. I have access to the logs inside my container. So that's a very useful command as well. And we're going to apply it as we move forward in a couple of situations as well. Podman PS, I can see my container is running. I can do various things to it. As you can see now it's stopped. I can start it again. And as you can see, I can see the port and information as well as when my container was started. Now, what about resource usage? So let's take a look at the processes inside my container. Again, top -L. I can see inside my container, I have core deals. I have HTTPD, and that's about it. So that's what's running inside my container and the resources that are being consumed. And if I want to check the statistics across all of my containers, I can use Podman stats. So Podman stats gives me a live stream of what is going on inside my containers. And as you can see here, I have that going on. I can also check my published ports. So port -L command will tell me that I have 8080 to 8080 inside my container. Okay, so now that we've done that, let's learn a bit about how we can clean all this mess up. Because what you'll usually find is that you have a lot of containers, right? Just one thing, once you do RM, remember that RM is forever. So what you haven't saved, if you have any state inside your container and you do an RM, then it's gone back to the image. I can also clean up the image. So if I do a Podman images, you'll say I have a bunch of images here. I can do a Podman RMI, and then I can delete the image. So if I run this again, you'll see that it's going to try to pull the image again. So that's one thing to consider. Okay, so we've done a couple of things with the images. We ran them, we started them. We did a bit of cleanup. Let's see if we can clean up a few more things here as well. So while this fetches, what I want to do is I want to delete everything. So Podman has a very useful command. It's called system prune. System prune will delete all stop containers, pods, dangling images, and build cache. So if you find yourself running out of disk space, consider this one, but hopefully you don't have any unsaved work. Okay, so far so good. We've learned how to run and manage containers. Let's see if we can build a container. And let's see if we can build a container from a Docker file, which is looks a bit like this. So inside the Docker file, you have this, which start from a base image. Here you can see I'm using a new universal base image, which is patched. It has Python 3.6. And I'm installing and upgrading Jupyter Lab inside that image using pip. I'm also exposing port 8888. It's a very, very simple build process. It will install and build Jupyter Lab from a universal base image. So let's take a look at this build step. I'm doing a build dot -t Jupyter Lab. I'm taking advantage of build cache, and my image has already built. Let's run it. So I'm running Jupyter Lab. In the background, I'm publishing port 8888, and I'm using this image. So let's take a look. It already exists and is in use. So probably shouldn't have tested all these commands before, right? I'm going to stop it. I'm going to remove it, and I'm going to run it again. As you can see, if I do a PS, I can see my Jupyter Lab running there. Remember what I told you about logs minus L. Logs minus L will give us the URL as well as the token to which we can log in. So I'm going to click it, and there we go. I'm running Jupyter Lab. Okay, and it's basically just as useful as any other, Jupyter Lab installation. Now, remember, when this container is going to be deleted, all of my data is going to be gone. So you'll probably want to attach some form of persistence with this container as well. So I'm going to jump into using Buildah and talking a bit about the universal base image as well. But before that, let me open it up to some conversations, questions, answers from the audience. I'm not sure if they can go off mute there, Luke, but if you have any questions, just unmute yourself or perhaps type them in the chat and I'll try to answer them.
Yeah, everybody should be free to unmute themselves if they want to chime in.
Okay, so no questions. Not sure if that's a good or a bad thing, but let's take it from there. Okay, so we have Jupyter Lab. We know Jupyter Lab is running and working. And now we want to take a look at some perhaps more advanced or easier to use build tools. So up next, what I'm going to do is I'm going to show you how you can use Buildah to build a container image using shell commands. So Buildah is very interesting to use, right? I say Buildah run, the name of the container. So here, for example, the name of the container is Buildah from Fedora, and that's where I start. And then I just run commands. DNF install, wget, tar, build a copy, commit, image, inspect, and Podman run, and we are good. So I'm going to show you how I can use this Buildah to run an image that downloads Pandoc and installs it inside the image. So I'm running those commands. It will now go and create an image from the Fedora base container, and then I'm just using plain shell commands instead of the run commands inside the Docker file. It's an easier way to build your image. You can take advantage of Buildah. It's very easy to use, and like any other tool, one of the advantages of Buildah is that it builds OCI compliant images. So you don't need to worry. They work with Docker, they work with Podman, they work in Kubernetes, they work inside OpenShift, and you can do it in a very straightforward way. So as you can see here, it's much easier to read and understand than using a Docker file and Docker commands inside a container. It also, one of the advantages here is that it allows you to create these containers without requiring any root privileges, right? So if you're building traditional containers using Docker and a Docker file, you'll find that you need a Docker daemon, it runs as root. The idea here is to build these container images using a regular process. And this comes into play with container registries. So for example, key.io or Quay, I'm not sure how to properly pronounce that. I'm sure there's a war going on between the pronunciation. I'm guessing The Irish way would be key. Did I get that right, Luke?
Who knows? I'd say key. Yeah, I'd say key.
Yeah, you say key. There we go. So here's one advantage of using Buildah for your image pipeline, right? Since it doesn't require a Docker daemon, it's very easy to integrate it inside a container image registry inside a CI/CD pipeline, so you can automate your builds and deploy your containers, and it will also take advantage of code scanning and vulnerability assessment tools. So my advice is to go to key.io and get an account. You should have a account for GitHub, an account for Key, and Podman installed on your machine if you want to take full advantage of the ecosystem and also of some of the code scanning and inspection capabilities that you see there. Okay, that's still building. I believe it's installing LaTeX for some reason. So that image is still building at the moment. So that's Buildah and universal base images. That's going to be your starting point for a lot of these images. It's a certified container image. It's secure. You know that it's being tracked. Somebody's watching it. And you can always see, check out the Docker file, check out what's being placed in this image, the health index, and get access to the latest information. And one thing to keep in mind as well is that all these images have been designed to run without the need for root. So they're unprivileged images, which tends to help if you have security in mind as well. Okay, so as you can see, Buildah has finished building my image, and it ran pandoc inside the image, and now I have the version inside my container image. Okay, that's it for the hands-on piece for today. I'm going to give you an overview of what we're going to show in our sessions next time. So please bear with me while I give you a very, very quick overview of that. So very quick overview of what you're going to see in our next sessions. We're going to spin up a OpenShift environment. We're going to push our image to key, and we're going to run the images that we've created in our sessions today on a Kubernetes and OpenShift cluster. We're going to take a look at scaling out the images and doing various things with our image, as well as how we can deploy, starting from source code, starting from a Docker file, from a container image, from a catalog, or from a image registry. One website I advise you to take a look at is learn.openshift.com. It's based on Katacoda, and you have access to OpenShift or Kubernetes environments within minutes. It takes roughly around a minute to get access to a full-blown environment where you can deploy your containers and your applications. So while this sneak peek of our session to next time is loading, let me do a refresh here. Do you have any questions? Okay. With that in mind, I will see all of you in our next sessions where we're going to deploy some applications from a developer perspective. We're going to take a look at how we can create applications, deploy applications, so create projects like my data project. And we're going to deploy the same Docker file that you've seen in the repository here that deploys Jupyter and was running on localhost. We're going to deploy it here. We're going to make sure the port is a match, and we're going to take a look at how this application is being deployed, built, and scaled onto a OpenShift cluster to multiple nodes, how it can be monitored, scaled out, debugged, how we get access to the logs, and all of the commands that you've seen today using Podman. What's the equivalent using kubectl or OC commands, or using the user interface, or how the build process is now running, as you can see it here, how you can access the ports, how you can bind ports to your container, and so on. So last chance to ask questions in the chat. All right. Well, either the chat is broken or we're being completely ignored here, Luke. So one of the two.
We are very shy. No, you are doing great. You are doing great.
All right. Thank you. Excellent.
Yeah, thanks, Mihai. That was great. Just to remind everyone, I did record that. So when WebEx kind of finishes churning that out, I'll get it up on the Meetup group for everybody's viewing pleasure.
All right. And what you'll also get is this. So if you want to follow on your own, you'll have a version of this. But please bear with me until Monday so I can make sure that everything we put in here is sufficiently clear for everybody to follow along in their spare time. So you'll get a link to a GitHub repository with the presentation as well as the Docker files.
Brilliant.
Okay.
Thanks, Mihai.
Cheers.
And thanks, everybody, for joining. We will hopefully see you next Friday.
Talk to you. Bye-bye.
Cheers, bye.